Alright guys, this last video in section 4.7 is going to deal with the inverse tangent function, okay? So what we're going to look at here is, first of all, here's the tangent function, just normal tangent, okay? Not inverse, this is just tangent. So just like I did with the last two, I'm going to talk about this one the same way. So if I look at this function, I kind of gave it away here, if you look at this graph, is this going to be a function? And the answer is yes, because it still passes the vertical line test. Okay? So now the next question I'm going to ask is its inverse a function? And just like the last two, the inverse is not a function because it fails the horizontal line test. I don't know if I misspoke. Let me make sure I said that right. It passes the vertical line test. I can't remember. It does pass the vertical line test, but it fails the horizontal line test. Okay, so if you draw a horizontal line, it's going to go through infinitely many points. Okay, we can keep drawing this. It's just going to repeat like this. We're always going to have asymptotes at negative pi over 2 and pi over 2 if we just have tangent x, and at odd multiples of pi over 2, I should say. And the zeros are always going to be at multiples of pi. Okay, so that's it pretty much. That's what I wanted to say with the graph. Now we're also going to write down the definition of inverse tangent. Now, actually, before we move on, one more thing I want to mention. We have to restrict the domain here. So, the reason why, if I just said, find the inverse tangent, or, we want to, okay, let me say it this way. We want to make inverse tangent be a function. So, in order to do that, we have to restrict the domain again. We have to restrict the domain of tangent. Now, a good domain to restrict it to is from negative pi over 2 to pi over 2. So if I were to erase this whole thing right here over, does that now pass the horizontal line test? The answer is yes, it does pass the horizontal line test. So we do have to restrict the domain from negative pi over 2 to pi over 2. Now, so that sounds very similar. Let me go all the way back to inverse cosine right here. No, my bad, I misspoke. Inverse sine. So if you look at this, look at what the range was. The range for the inverse sine is from negative pi over 2 to pi over 2, okay, with brackets. So the biggest difference between inverse tangent and inverse sine is pretty much the same interval, except, guys, you'll notice if you look at the graph at negative pi over 2 and pi over 2, those are going to be asymptotes. So we're not going to have graph there. We're not going to have a piece of graph at those points. So therefore, the only difference between the range of the inverse tangent and the inverse sine is going to be we're going to have parentheses instead of brackets, okay? Because the tangent of negative pi over 2 is undefined, and so is the tangent of pi over 2. That's undefined as well. So we're going to have to use parentheses. So let's go and write this down. Let me fix this real quick. Got a little mixed up. There we go. So the inverse tangent function, and pause it here. If you need to write this down, I'm going to move on really quickly. Let me read it real quick. Another name for it is arctangent, just like with the other ones. So the inverse tangent function is the unique angle y in the interval from negative pi over 2 to pi over 2 such that the tangent of y is equal to x. Sorry, I kind of emphasized that a little bit wrong. Such that tangent y equals x is the inverse tangent, which is the arctangent of x. Denoted y equals inverse tangent of x. You can write it like this to the negative 1 power, or you can write it as arctan x. Guys, essentially, again, I don't know if I did a good job explaining this in the last two videos. Guys, we're essentially changing our x and y values. That's what inverses do. We're doing the tangent of y is equal to x. Instead of normally we have tangent of x equals y. Okay, so just one more thing I want to write down. Make sure you guys know. The domain of the inverse tangent is from negative infinity to infinity. We can plug anything in. We can pick any number and plug it in for inverse tangent. Now the range, the angles we have to choose from are from negative pi over 2 to pi over 2. So again, it's going to be the right side of our unit circle. Okay, so I'm going to try to go through this real quick. We're just going to look at a few examples where we evaluate the inverse tangent of different ratios. Remember, when you evaluate inverse tangent, you're trying to figure out what angle do we have to have in order for the tangent ratio to be whatever, okay? So I'm just going to go through a couple examples. Now tangent's a little bit harder because you have to think of sine and cosine at the same time. Remember, this is just recall, tangent x is going to equal sine x over cosine x. So there's a couple things you got to think about. What's the sine ratio and what's the cosine ratio? All right, so like I mentioned, tangent's a little bit more difficult. All right, so let's go ahead and go through a couple examples here. Here we go. Let's just start with the inverse tangent of the square root of 3. Now I know that's kind of weird. It's not one of our important values that we talk about, 1/2 square root of 2 over 2 and square root of 3 over 2, but it is derived from those important values. Okay, it comes from those important values. So guys, I will never give you an inverse tangent problem. Well, let's say this. If I give you an inverse tangent problem that's not derived from from your 3 important values or from your quadrantal angles, then you're allowed to rely on your calculator for that. Okay. The ones I'm going to give you are possible to do by hand. Okay. To figure this out using special right triangles and things we've talked about in the past. Okay. So let's find the inverse tangent and using the unit circle as well. So inverse tangent of the square root of 3. Now here's what I want to talk about, guys. This, like I said, this is the way I think about it to figure out what angle does it have to be. So again, you need to ask yourself the question, what does the angle have to be in order for the tangent ratio to be square root of 3, and let's just call it right there, yeah, it's square root of 3. Okay? So what did the angle have to be in order for the tangent ratio to be the square root of 3? Well, guys, remember, tangent of the square root of 3 what am I saying here? Sorry. Wrong. Erase that. That's bad. So let's say that the tangent of, well, x, the tangent of x, is always equal to sine of x over cosine of x. We wrote it down before. But think about this. So if tangent is always sine x over cosine x, that is a division problem. Sine x divided by cosine x is a division problem. So here's what I want you guys to do. Type in the square root of 3 into your calculator and just try to figure out what that is as a decimal. Okay? So just type it into your calculator, square root of 3. I did that. I don't know if it focused on it. 1.732. Okay? So guys, this is approximately, sorry, I'm not answering this, guys. Let me write this off to the side. So the square root of 3 is approximately 1.73. The reason why I told you guys to type it in like that, what I want to ask you guys is, if we get a division problem, if we know the sine over cosine is going to equal 1.73, if you get a division problem and your answer is bigger than 1, what do you know about the relationship between sine and cosine? Okay, so let me say that again. If you're doing a division problem, we've got sine over cosine. If you know you take sine divided by cosine and your answer is going to be 1.73, then what's the relationship between sine over cosine? Which one's going to be bigger? Is sine going to be bigger or is cosine going to be bigger? And the answer is sine, okay? If you get a number bigger than 1 when you divide, the top number, the numerator, is going to be bigger than the denominator. Okay? It's going to be a little greater than it. So that's what we need to use, guys. So if you look at your unit circle, and again, we want this to be positive. We're saying the inverse tangent of positive square root of 3. Okay? So if we want to look at the unit circle here, where are our sine values bigger than our cosine values? So let me give you an example here. So let's start with pi over 6. Here, let me get a marker on here. So at pi over 6, what are our sine values there? The answer is 1/2. At pi over 6, what are our cosine values? And the answer is square root of 3 over 2. So this is not the angle we want because sine is less than cosine. Okay? So that's not the angle we want. Let's keep going. Pi over 4. Well, what's the sine value of pi over 4? The answer is square root of 2 over 2. It's the middle value. What's the cosine value, the y value? It's going to be square root of 2 over 2. It's the middle value as well. So square root of 2 over 2 and square root of 2 over 2, those are equal. So if I divide those, it's going to give me 1. So that's not what we want. So the one left is going to be pi over 3. So guys, sine is going to be square root of 3 over 2. The y value, that's going to be square root of 3 over 2. And the cosine value of that is going to be 1/2. So that is going to be the angle I need to choose. Now, this angle would work, and also, actually, this angle would work, wouldn't it? think about that. With tangent, I'm dividing sine and cos. So wouldn't this be a negative square root of 3 over 2 for sine? And wouldn't this be a negative 1/2? So when I divide negative by negative, it's a positive. So the answer to the question, what angle does that happen? It's either pi over 3 or 4 pi over 3. But which one can I throw out? And the answer is 4 pi over 3, because with tangent, inverse tangent, I want to pick angles from negative pi over 2 to pi over 2. Okay? So the reason I throw this angle out is because I want to choose from negative pi over 2 to pi over 2. That's the limited range that we have to choose from. So guys, the answer here is going to be pi over 3. So let me explain this one a little bit further. Okay? So the reason that tangent of x is equal to square root of 3 in this case, let me write this down. So guys, it's because the tangent of pi over 3 is going to equal the sine of pi over 3 over cosine of pi over 3. And we know the sine of pi over 3, we already talked about it, is the square root of 3 over 2. The cosine of pi over 3 is 1/2. So instead of dividing by a fraction, we can multiply by the reciprocal. So multiply by 2 over 1 here. So I'm choosing not to divide by 1/2. So those will cancel, the 2's, and so we're left with the square root of 3. So the reason this works, the reason why the inverse tangent of the square root of 3 is equal to pi over 3, that's because the tangent of pi over 3 is equal to the square root of 3. So see how we're just switching the x and y values there. Okay? So that's the idea. Let's do another one. What if I said, what is the inverse tangent of, how about negative 1? Put a question mark. Sorry, this would be part B. Scroll back up. There we go. All right, so part B, what's the inverse tangent of negative 1? Well, guys, again, you need to think this. What did the angle have to be in order for our tangent ratio to be negative 1? So, let me write this down. So remember, tangent again is sine over cosine, and we want that to be negative 1. So forget about the negative for right now. If let's say we wanted our tangent ratio to equal 1. So guys, think about what the angle would have to be if we want our tangent ratio to equal 1. Well, that would be something, don't we have a division problem here? So how is it possible to divide two numbers and get 1 as your answer? So like I said, don't pretend there's no negative there for right now. We'll come back to that. But how do I divide it? If I divide a number by another number, if our answer is 1, what's the relationship between those two numbers? And the answer is they have to be the same. Okay? So we want to figure out, where is sine and cosine the same? Well, sine and cosine are going to be the same at intervals of pi over 4. Okay? Those are both going to be the middle value. So pi over 4, they'd be the same. 3 pi over 4, one of them would be positive, one of them would be negative. Sine would be positive, cosine would be negative. 5 pi over 4, sine would be negative, cosine would be negative. And 7 pi over 4, sine would be sine would be negative, cosine would be positive. So it's one of those angles. Now let's try to determine which one to choose. And that's where we think about the negative here. So guys, how is it possible to get a negative value? Well, if sine is, if one of these are negative, okay, only one of them has to be negative. So either if sine is negative or if cosine is negative. So let's look back at our unit circle. We said it had to be an interval, it had to be a multiple of pi over 4. And if we want the tangent to be a negative value, guys, remember we can only choose from these two quadrants, quadrant 4 and quadrant 1. So if we want tangent to be negative, tangent's going to be positive up here because we'd have sine over cosine, which would be a positive divided by positive, which is positive. Tangent's going to be negative down here. So this is the value we need to choose. That's the point we need to look at. Now, can we call our answer, so this is similar to sine, are we allowed to call our answer 7 pi over 4? And the answer is no. We're not allowed to call it 7 pi over 4 because it's not in the right interval. We want it to run from negative pi over 2 to pi over 2 up there. So 7 pi over 4 is outside of that interval. It would be when we open it up and we go past pi over 2. So guys, I need to rewrite this as its coterminal angle. It's negative coterminal angle, so that's going to be negative pi over 4. That's going to be our answer. So negative pi over 4, let me explain this a little bit further. The reason this is the correct answer is because the tangent of negative pi over 4 is going to be the sine of negative pi over 4 divided by the cosine of negative pi over 4. So the sine of negative pi over 4, if you look at your unit circle, is going to be negative square root of 2 over 2. The y value is negative, so that's going to be a negative square root of 2 over 2. And we're going to divide that by the cosine ratio, which is going to be a positive square root of 2 over 2. Well, guys, when we take any number divided by itself, the answer is 1, but we have a negative divided by a positive, so it's going to be a negative 1. And so that's why, guys. That's why our answer works. All right, just one more real quick. What if I said, find the inverse tangent of 0? All right, here's what you need to ask yourself. This is part C. So, what did my angle have to be in order for my tangent ratio to equal 0? Okay? So again, tangent is always sine over cosine. Now, we want this to be equal 0, don't we? So think about this. If we want this to be equal to 0, how is it possible to divide two numbers and get 0? Where would the 0 have to be, on top or on bottom? Guys, remember, if we divide by 0, that's undefined, isn't it? So what we need to do is have 0 in the numerator. Okay? So, if our sine ratio is 0, then wherever the angle that makes that happen, that's going to be our answer. Okay? So let's try to figure out where sine is equal to 0. So guys, what is the angle from negative pi over 2 to pi over 2 where our sine ratio is equal to 0? Now remember, sine's y values, and hopefully you know it's this right here. So that point right there. So that right there is 0 degrees / 0 radians. So the answer here, the inverse tangent of 0, 0 radians. There we go. Again, just to make sure you guys understand this, the tangent of 0 is going to equal sine of 0 over cosine of 0. Sine of 0, the y value of that point is 0. The cosine value of that point is 1. 0 divided by 1 is 0. So the tangent of a 0 radian angle, or a 0 degree angle, is going to be sine of 0 over cosine of 0, which is 0 over 1, and that whole thing is 0. So guys, what does the angle have to be in order for the tangent ratio to be 0? The answer is 0. Okay? Alright, hopefully that makes sense. Went over a few examples there. Guys, I'm going to leave you other videos. So if you didn't understand anything from this section, or if you just want more practice, watch those other videos. Seriously. Seriously, guys. Watch them. Okay? So those are optional. You don't have to, but if you don't understand this, if you need help on your homework assignment, you might want to watch the other video. There's a good video on there by another teacher that has on there that she might have covered some things I missed. I can't remember exactly, but I remember watching the video. I remember thinking it was good. So you might want to watch the other video / videos. I don't know how many I have on there, but if you need help. Okay? That's all I got for you guys. Thanks.